Welcome back to DM News. Today we'll be focusing around the topic of gasoline prices and how the wealth of a country can impact it. As you may have noticed lately, gas prices have been going up. From 1980 to 2012, Canada's per capita income has tripled in value.
This means that as the per capita income of our country increases, so does the gas prices. This is believed to be because gas companies want to continue to make money. If a country is making more money, then they will be able to spend more on gas. Whereas if a country is making less, they won't be able to spend as much on gas and will end up going in debt.
Gas prices are a very popular topic to talk about. Like Meaghan said, gas prices have gone up a lot. The price of WTI crude oil has been $56 to $57 a barrel, with approximately 42 US gallons in each barrel. This calculates to a price of crude oil to 35 to 36 cents per liter. This compares to each country of how much the prices of gas differ and how much they are the same.
This is important information to have because people often wonder how we were paying less than $1 not too long ago, but are now paying well over $1 per liter. Having this information and being able to compare it with other countries around the world makes it useful in understanding the price of gas itself, as well as how gas companies are making money off of it.
We have found information on the petroleum prices in relation to the per capita income of wealthy countries versus less wealthy countries. To determine the wealthy versus less wealthy countries, we split the data into the top 75 countries and the bottom 75 countries in terms of how high their per capita income is. We then found the mean and median of petroleum prices within each group and concluded some results.
As you can see, when the mean was calculated for petroleum prices in wealthy countries, it was found that on average the petroleum prices was approximately $1.22 in comparison to the less wealthy countries who on average pay approximately 94 cents for petroleum. To put this in perspective, the median was calculated after this, and it was found that the median for wealthy countries was $1.24, whereas for less wealthy countries, it was 94 cents. Between the wealthy and the less wealthy countries, there is a difference of approximately 28 cents in average price for petroleum. These calculations mean that for wealthier countries, gas companies are able to charge more knowing that people are making more money and able to afford the higher price of gas. For the less wealthy countries, the average price of gas is lower because gas companies know if the price is higher, people won't be able to afford it and therefore won't make any money. This means that they need to lower the price of gas for the less wealthy countries in order to still make money. And comparison between the two, depending on where you live in the world, will affect how much money you spend on gas.
The next thing that was done to get a better understanding of the data and the comparison between the two was to make a histogram. This provided us with a visual representation of how the data is similar and different between petroleum prices in wealthy countries versus less wealthy countries.
As you can see in the histograms, the distribution for each strata is left skewed. Both histograms show the majority of the data on the left side of the chart with a small outlier in the less wealthy country's histogram. A left-skewed histogram consists of the mean being less than the median due to the data having few small values that bring the mean down slightly. When looking at the histogram in comparison to the mean and median from earlier, this is true. The data for both histograms is shifted towards the left side, and the median is slightly higher than the mean for both of the wealthy and less wealthy countries.
We then created a box and whisker plot. A box and whisker plot is used to show the shape of the distribution, its central value, and its variability. It shows the upper and lower ends of the data, called the upper and lower quartiles, as well as spans the entire data within those ranges, called the interquartile range. For our box and whisker plots, we have created one for wealthy countries and one for less wealthy countries, and compared and analyzed the data.
As you can see in the box and whisker plot, there were two outliers in the less wealthy country plot. This is shown by the two dots on the opposite end of the data range. This is thought to be the case because there could be only one country that is significantly higher and significantly lower in the amount of money that the country has in comparison to the others that were found in the data. This means that the petroleum prices for those countries would be significantly higher or lower than the other countries. That is being compared with on this box and whisker plot. This may have occurred because when we split up the data between wealthy and less wealthy countries, we divided it up by the top 75 and the bottom 75 in amount of money charged for petroleum prices, which determined this split.
This could mean that the outliers are on the higher and lower end of the less wealthy, but based on where we split the data, it ended up being an outlier in comparison to the less wealthy countries it was paired with. In the wealthy countries box and whisker plot, there were no outliers. This is because all of the data in the wealthier countries, it is very consistent and there is no countries that are significantly wealthier than the others. Based on where the data was split, all the countries are relative to each other, making no outlier in this set of data.
What was conducted next was finding the standard deviation between the two sets of data. As you can see, the standard deviation for petroleum prices in wealthy countries was approximately 38 cents per liter in comparison to the less wealthy countries who had a standard deviation of 42 cents per liter. As you can tell, the strata is slightly different from each other but relatively close. Standard deviation shows how measurements from a group are spread out from the average or expected value. A low standard deviation means the most of the numbers are close to the average, and a high standard deviation means that the numbers are more spread out. In this strata, the wealthier countries have petroleum prices that are close to the average and are less spread out, but the less wealthy countries are farther from the average and the numbers are more spread out. This means that the wealthier countries are more consistent in their petroleum prices and the less wealthy countries are less consistent in their petroleum prices.
The last comparison between the set of data was making a scatter plot and calculating the correlation coefficient. This showed a distinct difference between the two sets of data and gave a very good visual representation of what the data actually means. Comparing the correlation coefficient, you can see that the wealthy countries have a higher correlation of approximately 0.370, where less wealthy countries have a correlation of approximately negative 0.150. To describe the correlation of the data, you can see that the wealthy countries have a weak positive correlation, and the less wealthy countries have a weak negative correlation.
In conclusion, countries that are more wealthy have higher gas prices than less wealthy countries who have lower gas prices. For the wealthy countries, they have a weak positive correlation, which means that as their per capita income of the country increases, so does the gas prices. This makes sense with what we found because the more money the country makes, the more gas companies can increase their petroleum prices, knowing gas will still be bought. For the less wealthy countries, they have a weak negative correlation, which means that as the per capita income of the country increases, the petroleum prices don't always increase as well. We found that this could be because for less wealthy countries, their per capita income either doesn't change or could change often. This means that within a few weeks, they could drop or raise significantly without any indication of this happening. This means that gas companies don't want to necessarily always raise their prices when their per capita income increases, because they know it will drop and therefore the price of gas will temporarily be too high. Overall, this means that depending on the amount of money a country makes, it will affect how much gas companies charge for petroleum. For the most part, we have found that when the per capita income of a country increases or decreases, so does their gas prices, so that gas companies can still make a profit.
Of course, with every set of data, there is always some bias, limitations, or assumptions that need to be made before analyzing. One reason that the data may not be fully accurate is because we made the assumption that there are a similar amount of people buying gas in each country, and the gas prices were a product of the per capita income, and not the presence or lack of supply and demand or accessibility of gasoline. Our data may be skewed if there are vast differences in the number of consumers. For example, the majority of America's population, upwards of 3 million, are gasoline consumers, whereas in less developed, less wealthy, or smaller countries, the number of consumers would be drastically lower, and that would affect the price of gasoline, regardless of the per capita income. Additionally, some countries are moving away from the use of gasoline, despite size and wealth, because of the impact it has on the environment, or they are implementing taxes to deter people from buying gasoline, which can decrease the accessibility if there is no demand. In relation to the previous points, not everyone is buying gas for various reasons: wealth, environmental concerns, lack of accessibility, etc. Yet the data compares income of all citizens to the price of gas, which is for the most part affected only by the people who are buying the gas, whereas the per capita income represents the income of all citizens regardless of if they are purchasing gas.
Another bias or limitation is that things have obviously changed since the data from this website has been released. There's been a shortage of gas recently around Ontario, especially. Dan McTeague from GasBuddy.com says we're seeing a tightness in supply here in Ontario because 2 of the 3 refineries in Sonera are experiencing some difficulties, meaning they don't really have a lot of supply right now. Dan also says that the refineries belonging to the Imperial Oil and Suncor. This means that there will be a shortage at Esso and Petro-Canada stations first, also meaning that gas prices will have to be raised. Petroleum prices differ among every country. Generally, richer/wealthier countries have more higher prices, while poorer and unwealthy countries that export the oil have significantly lower prices. For example, looking at America, which is a very economically advanced country, has lower gas prices. The different gas prices around the world vary and change due to taxes and subsidies for gasoline. All countries have to access the same petroleum prices of international markets, but taxes on it is what makes it different. This results in the retail price of gasoline changing and being different.
The last bias or limitation is that the information on the website could have just included the countries that they could find information from. By only including the countries that are available, it allows us to split the data based on the information that we had instead of the actual top 75 and bottom 75. This could create bias or invalidity because if countries are missing with relevant information, then where we split the data could have been incorrect and given us more outliers. When we look at our box and whisker plot that we made with our data, there was a couple outliers that we found in each set of data that we had. There was one below and one above the normal set of data, which means that one country had a significantly lower and one had a significantly higher petroleum price in relation to the other data within the chart. If there was more data from all the countries in the world, there might not have been these outliers because the information and data would have been more relative to each other.
Well, that's all we have for you today. We'll see you next time on
DM News.